Hey, today I'm going to talk to you about open and closed systems. Okay, so in order to apply the conservation of mechanical energy in order to solve a problem, we first got to define what the system is that we're considering. All right, so, and systems, that's a kind of a big idea in physics, and it might take a little time to wrap your head around it, but here's a basic idea. So an object is just a single thing. It just doesn't have any kind of internal structure or interest. It's just a thing, right? But a system is two or more objects that are somehow interacting with each other. And that's what we're mostly interested in physics, is how systems interact, okay? So the thing about mechanical energy is if the only forces acting between the objects in a system are conservative forces that are acting between the objects that make up the system, in that case, the ME of the system will remain unchanged. So we have conservation of mechanical energy. All right, but that's not always going to be the case. So we've got to be careful. In order to apply the conservation of mechanical energy, we've got to make sure what our system is. So that means we need to talk about the difference between open systems and closed systems. And this is important, so please listen up. A closed system is the special case in which all the work is done by conservative forces that act between objects that are part of the system. So the forces that are acting are conservative. In the case of this class, that means they're either spring forces or gravitational forces. And that's acting between objects that are both part of the system. In that case, all the mechanical energy is conserved. It remains the same throughout the system. So that would be a closed system. Now, an open system is going to be one in which either we have external forces acting on the system, or we have non-conservative forces acting within the system, or external to the system, either way. But the thing is, these forces are therefore going to do work on the system and change its mechanical energy. Since energy is either added to or removed from the system, the energy in the system changes, and therefore we cannot consider it to be a closed system. So that's the difference between those two. Let's just see what we do next. Okay, so I'm going to give you an example of an interaction in a closed system here. So what I've got for you here is a series of 3 diagrams, and I'm showing you a system that consists of just 2 objects, object A and object B, and a spring that's connected to object B. Now they're on a frictionless surface. I'm not including that as part of the system though, okay, but it's not going to exert any force on the system. So this system, it turns out, is going to be a closed system, and here's why. If you look, both these objects are moving towards each other, and they both have 10 joules of kinetic energy. All right, and the spring is in a relaxed state, so there's no spring energy there. So the ME of the system at this point is 20 joules. We have 10 joules here and 10 joules here. Now, at the moment of collision here, what happens is, let's just assume that there's a moment where both A and B have come to rest, but all of their energy is present now. Notice their kinetic energy has gone to 0, but all their energy is present now as 20 joules of spring potential energy. Spring energy is a conservative force active between the objects that make up the system, object A, object B, and the spring. All right, and so we haven't lost any mechanical energy. It's still 20 joules. Now, the spring is going to exert a force on object A and object B, pushing object A to the left and object B to the right. And afterwards, the spring no longer has any spring potential energy, and both the objects have gone back to having 10 joules of kinetic. So the ME of the system never changed at any moment during this. That makes it a closed system. So we had a situation in which we had a conservative force, spring, acting between objects that are part of the system, and therefore it was a closed system. Okay, now we're going to do the same thing, except now it's no longer a frictionless surface. Notice now this surface has friction associated with it, right? So to start off with, the same scenario is that we have object A, object B, both moving towards each other with 10 joules of kinetic energy, but they're on a frictional surface. Okay, now there's 2 things here. One, friction is a non-conservative force, and 2, it's external. It's not part of the system. This table is not part of the system, and even if it was, it wouldn't matter because it is a non-conservative force. So now what happens is, because these things are in kinetic friction, by the time they actually collide, and they're just like they did before, their kinetic energies are going to come to 0. But what we find is the spring doesn't compress as much, because on the way to that midpoint where they collided, they were both losing energy to friction. So when they do come to rest and compress spring, it only has 15 joules because they each lost 2.5 joules getting there. Now the spring pushed them apart. They're sliding apart again on a frictional surface. It's still doing negative work work on each object, right? It's always working against their motion, doing negative work. Now each object only has 5 joules. The spring doesn't have any, but that means the ME of the system is now 10. So notice I went from 20 to 15 to 10. That makes it an open system. I'm losing mechanical energy in this case because I have a non-conservative force, friction, that's acting between objects that are not part of the system. And even if they were part of the system, it wouldn't matter. Now this is one that's you really need to think about this one, okay? So this is kind of cool. So let's consider this. We're going back to having a frictionless surface, okay? And if it's a frictionless surface, then I don't only have that external force and a non-conservative force acting between the objects. So they each have 10 joules of kinetic energy as they approach each other. So the mechanical energy system is 20. But this time what's going to happen is they're going to collide and stick together. There's no spring in this case. So both of their energies go to 0. Now, it's important to understand that energy itself is always conserved. Mechanical energy doesn't have to be conserved, but energy itself does, right? The total energy of the system. And in this case, what happened was the kinetic energy, which was a form of mechanical energy, got converted in the collision into random atomic kinetic energy, and we call that thermal energy. And thermal energy is not considered to be mechanical energy. It can't be converted back into kinetic. So basically what happened is the temperature of these objects went up by a total of 20 joules. So if I looked at how many joules of thermal energy they had prior to the collision, after the collision, they now have 20 joules of thermal energy because I lost 20 joules of kinetic. So the mechanical energy of the system went from 20 to 0, and that means it's an open system. The force was acting between objects that are part of the system, but it was a non-conservative force, the normal force. And the ME of the system changed, so therefore it's an open one. And by the way, it should be pointed out that thermal energy cannot be contained in the system. There's no way of keeping thermal energy anywhere. It always has a way of leaking out. It's something that's pretty cool called the second law of thermodynamics. Something they cover more in chemistry than we do in AP Physics 1. I think they do it some in AP Physics 2. But the bottom line is you can't contain it. So the system is open in the sense that energy is going to leak out of the system now. But the main thing is it's not mechanical anymore. Okay, well, let's try this. All right, let's look at the definition of the system matters, okay? So here we're going to say our system is the Earth object system. Now, listen, when you're doing your AP test, you need to look. When it defines the system, you should circle it in it and say, okay, what objects are part of the system? This is the Earth object system. I should have capitalized object. Sorry, I didn't, okay? And since Earth is part of the system, there's a conservative force, gravitation, acting between the Earth, which is part of our system, and the object, which is part of our system, okay? Therefore, it is possible to have gravitational potential energy. So in this case, the kinetic energy, this object is at rest, I have 100 joules of gravitational potential energy, and therefore the mechanical energy, which is the sum of these two, is 100. As it falls downwards, this conservative force is going to convert gravitational potential energy into kinetic energy in equal amounts. So right before it impacts the ground, what I find is I now have 100 joules of kinetic, 0 joules of potential, and the ME is still the same, 100 joules. So in this case, it's a closed system because at this point, no energy has gone into or out of the system, and only a conservative force, gravitation, has acted between the two objects that make up the system. But now look at this. What if I said the system did not include the Earth? It's just a rock falling. That means then that gravitation is an external force to the system because the Earth isn't part of our system and the Earth is what's causing the force. So there's an external force acting on this. It's really not even a system, it's just an object, but it could be a system, right? But in this case, it's just this object. So since the Earth is not part of our system, I can't have potential energy. So in that case, the mechanical energy of the system is just 0. I don't have any kinetic energy, and I can't have any gravitational potential energy if Earth isn't part of the system. Now, obviously, the object is going to still hit the ground with 100 joules of energy, but in this case, it's because Earth is an external force acting on it. And so if an external force acts on the system, it changed the mechanical energy of the system. It went from 0 to 100, and therefore that is an open system. Tricky, huh? Got to pay attention to what's in your system. All right, let's try another one. Let's say the system is defined as consisting of the Earth and a rock, but not the spring. If that's the case, there's no such thing as spring potential energy. The spring is an external force, even though it's a conservative force. In this case, it can't be because it's not acting between two objects that are part of the system. The spring itself is not part of the system. So what happens then is this is an open system. I start off, I can have, in this case, gravitational potential energy because the Earth is part of my system. Don't have any kinetic, so my mechanical energy to start with is 100. Now, as it interacts with a spring, what happens is the spring is, we don't consider having spring energy. We just say the spring is doing negative work because the kinetic energy has been reduced to 50, and I don't have any gravitational potential energy because I'm setting this as the 0 point for potential energy. So therefore the mechanical energy has gone down to 50. That means it's an open system. Because the spring wasn't part of the system, it makes it an open system because it applied an external force. All right, let's do the opposite. The spring and the rock are part of the system, but gravity isn't. Same thing. Now look, okay, now if gravity is not part of the system, then I can't have gravitational potential energy. So the mechanical energy of the system is 0. When I collide this, what happens is I'm going to end up having at this point I have 50 joules of kinetic energy and 50 joules of spring potential energy, but that means that the energy of the system went from 0 to 100. All right. Well, how did that happen? Well, because the Earth did positive work on the system. It caused it to gain energy. Earth is an external force in this case, and gravity is, and it did positive work on the system. Now, keep in mind, what I call a system in no way changes the outcome, just what I'm going to consider the system to be open or closed. Now, if it was the Earth spring rock system, and college will be very specific about this, in this case, I only have conservative forces, spring and gravitation, acting between objects which are in the system. Gravity is between the Earth and the object, which are both part of the system, and the spring forces acting between the spring and the object. They're all part of the system. And so in this case here, I'm going to see I start off, I have 100 joules of potential energy, no spring energy, no kinetic energy, so my ME is 100. As it collides here, it's going to slow down. So this is going to be 40 joules. It gained 40 joules of spring potential energy. Let's say at this point here, it has 20 joules of gravitational potential energy. So the system, the mechanical energy of the system stayed the same. One of the things that has to be true for it to be an open system, a closed system, and all the forces were conservative forces acting between objects that are part of the system. Hey, that's it. Okay, thanks for watching. I'll see you in class tomorrow.